Hello SG group and YouTube users. I want to show my current progress on my project. First I will go through my devices, measuring devices. Here you can see the voltage of my charging battery. This battery was previously discharged to 10 volts and then it was taken in 3 or 2 days in idling. It means no charging, nothing, no load. The resting voltage of my battery currently 12 volts. Okay, so here you see the amperage which will be measured for the charging battery. I'll take better view, not much light, but I will do my best. Okay, next. Here's the measuring voltmeter for the amperage of my primary battery. Here is a measuring voltmeter for my primary battery, measuring voltage. System currently switched off. Here you can see the scope of my device. Yep, and I will start the system right now. I will power on my system, and then I will move the wheel. Okay, let's look first, of course, let's look at the spikes which I get. As you can see, I have a lot of spikes which I can catch. 1, 2, 3, 4, 5, 6, 7 spikes which I get when system runs. And look at the wheel. You see the wheel, you see this part which I point with finger. It's a cutted paper board, cardboard, if I'm better to say, in form of blades. It's additional load for the wheel. Wheel, I will say, balanced not so good, but for me it's not bad thing, because I get what I want. I mean, such a lot of this kind of spikes, and I think it's very important if you want to get very good results for charging your battery, because you're charging your battery with these spikes. Now, what we see at the voltage of primary battery. What's happening to the primary battery? You can see the primary battery is fully charged and voltage not dropping very fast. It's a good sign, because I want that my primary battery discharge not so high. The rate of my primary battery is not high discharge. That it's discharging with not high rate. Okay, here you can see the current which I spent to run the system. It's 53 milliamps to run this wheel and to get such results which I am getting. And I will show you next thing. Okay, here is my connection. You can see probe scope attached to the meter and the tip to the collector. And here you can see the current of what I get for charging my battery. This is I get when I charge my battery. It's 20 milliamps. Here is my charging battery, and here is the voltage of my charging battery. You see the sudden increase in voltage, 12.12, and previously it was 12.0403, like I said earlier. Okay, and you can see current going through this device, and this current go to this battery. But what really charges the battery, it's not the current which I get, it's the spikes which I get. This is impulses. You can count these impulses already which I get. I hopefully now you see better picture, because my previous recording was not so good with a cheap camera, but now I got very good HD camera, and I can show you my current setting at my oscilloscope device. I have 0.5 volts per division. Time delay, it's 1 millisecond per division, and yeah, other rulers which I get here. I'm measuring DC, ground, no DC. Then it's okay. I think you can see all these things which I show currently. Focus, yeah. Intensity. This is name of my oscilloscope. Voltgraph, of course, because I'm doing this kind of experiments in Germany, and Voltgraph is very good manufacturer for such things. Probably cheapest most. This is the reason which I use this device. It was very good price. But understand this, only when you get very good impulses like this, only then you get results which I got. If you saw my table of charge and discharge of my battery, you saw the rate of charging of my battery, and I think with the 53 milliamps which I currently now spend to run this thing, I think it's very efficient currently in our system. And I show you once again the voltage which I get, 12.75 volts. This is voltage which I currently have on my primary battery, so it's not, it shouldn't drop voltage very fast on primary. Keep this in mind, because primary battery runs the system. It runs the system and produces the current which I then translate in something else here, in the high impulses. Okay, now I will look to the amperage of my charging battery. It's 20 milliamps currently, and now I have here the voltage of my charging battery, and you see this continuous increase of the voltage. And I must point additional thing with this 12 volt of start of this experiment which I currently run. In my previous charging experiments I never got such good idling voltage, meaning when the battery was resting and then voltage increase itself. So if you get such results with 4.5 amperage amp hour battery, then it's very good, and you're probably on the good way. Okay, what I must point you, very important, you can see probably not so good, the height from my coil and the wheel. I hope it can be seen. So it's like 4 millimeter. So it's very important, the height where your magnets the height between coil and the magnets on the wheel. It's very important. It's in some cases you should adjust it to your situation. Okay, now we'll look once again on the voltage of my primary battery. it's sitting at like this. So once again, if your primary battery discharge rate is higher than your charging rate of charging battery, then you done something wrong. In my case, it's all green, it's all okay. Here we can see the milliamperage which I spent. It's continuous 54-53 milliamps of the whole system. So it's very interesting. It's very interesting for me. And once again, this is spikes. This is H type spikes which I get. Let's try to play a little bit with this setup. What I can change here? I will adjust the probe adjust. Okay, nothing happens. I think this is better to say like this. Intensity, I adjust intensity, and just making the light off. Okay.